Okay, so what are quadratic equations? So they are just equations in the form ax squared plus bx plus c equals 0. So where a, b, and c are just numbers. It can be any numbers. They can be positive, they can be negative. The only important thing is that a is not equal to 0. Because if a is equal to 0, then this term cancels out, and then you're left with bx plus c equals 0. So that becomes a linear equation. So this is a linear equation, and then the whole thing with ax squared is a quadratic equation. So, for example, what does a quadratic equation look like? So 7x squared plus 2x plus 5 equal to 0. That's a quadratic equation. What if you had 7x squared plus 2x plus 4 equals 3? Is that a quadratic equation? Yes, because you can bring the 3 to the other side, and you're left with 7x squared plus 2x plus 4 minus 3, that's plus 1, equals 0. So you can make this into a quadratic equation. So that is also a quadratic equation. What's not a quadratic equation is 2x plus 3 is equal to 0. That's not a quadratic equation. Or x cubed plus 4x squared plus 6x plus 5 equals 8. That's not a quadratic equation because it has an x cubed term, so that's a cubic equation. But we won't go into that too much. So how do you actually solve a quadratic equation? So let's say you had an equation. Let's say we had x squared plus 6x, let's say plus 5 equals 0, right? Well, let's remember how to factorize. So what two numbers add up to positive 6 and multiply to positive 5? Well, you can have positive 5 and positive 1. So let's try those. So you have x plus 5 times x plus 1 equals 0. If you expand these brackets out using FOIL, then you would end up getting x squared plus 6x plus 5 equals 0. Well, either this bracket is equal to 0 or this bracket is equal to 0. So either x is equal to negative 5 or x is equal to negative 1. And those would be the solutions to our equation. But that's a very simple equation. Most equations you will not be able to factorize. So let's say you had x squared plus 3x. Let's say we had minus 2 equal to 0. How would you factorize this equation? There is no way you can factorize. No two numbers that you can think of at the top of your head would add up to positive 3 and multiply it to give you negative 2. Or at least I can't think of them right now. So what we can do is we have three other methods of solving quadratic equations. We can either graph the equation, or we can do something called completing the square. So we can complete the square, or of course we can use the quadratic formula to solve a quadratic equation. So there are four ways of solving quadratic equations, and factorizing is the easiest one, but it also has the least uses because most equations you won't be able to factorize. So a graph, yes you could, it will always work, but it takes a lot of time to do. Completing the square and the quadratic formula are actually related. So if you do something called completing the square on this equation right here, maybe I'll make a video on this or a short video on this. But if you complete the square on this equation right here, you end up getting the quadratic formula. So these two are related to each other for sure. But let's actually complete the square for an equation. So let's say you had x squared plus 3x minus 2 equals 0. Let's remember something from factorizing. So if you had a plus b times a minus b, you end up getting a squared minus b squared. We need to remember this. So now let's do it for x squared plus 3x minus 2. So the way you do it is you take the second term. So you take 3 right here, positive 3, right? You divide it by 2. So you have x plus 3 divided by 2 is 1.5. So let's work in decimals. So you have 1.5. You square all of that, right? So what would you end up getting? You would end up getting x squared plus 1.5x plus 1.5x plus 1.5 squared, which is equal to x squared plus 3x plus 2.25. But you don't want this 2.25. You want x squared and 3x. That's perfect. But you want a negative 2 instead. So how do you go from 2.25 to negative 2? What would you do? Well, you just subtract negative 4.25. So if you had x plus 1.5 squared, well, that's just this, right? If you subtract negative 4.25 from this, equal to 0, you'd end up getting exactly this thing right here. Well, this becomes a pretty simple equation to solve because you have x plus 1.5 is equal to x plus 1.5 squared is equal to 4.25. And if you square root both sides, then you're left with x plus 1.5 is equal to plus or minus the square root of 4.25. Right? And now it's very easy to solve. You have x is equal to negative 1.5 plus the square root of 4.25, and you have x is equal to negative 1.5 minus the square root of 4.25. So you can see, completing the square, very simple, very easy, and gives you the answer. So let's do another example with completing the square. So let's say we had 2x squared plus 8x minus, let's say, 31 is equal to 0. Let's see wanting to complete the square for this. Now, there is a way to complete the square with this 2, but I just like getting rid of the 2, getting rid of the coefficient of x squared whenever I'm completing the square. So let's just divide everything by 2. So you're left with x squared plus 4x minus 31 divided by 2. That's fine, that's totally okay, is equal to 0. Well, you can complete the square for this right here. So you're left with x plus, you divide 4 by 2, so you're left with x plus 2 squared. Well, if you open this bracket, you would end up getting x squared plus 4x plus 4, and we want to go from 4 to negative 31 over 2. So how do you go from 4 to negative 31 over 2? Well, you subtract, right? So if you do 4 minus, let's say 4 and then minus 19.5, that is 4 minus 39 over 2, you'll end up getting negative 31 over 2. This is negative 15.5, which is negative 31 over 2. So you're left with, so you have x plus 2 squared, and then you have plus 4, but you don't want plus 4, you want negative 31. So instead of plus 4, let's do negative 39 over 2 is equal to 0. Well, you can bring that to the other side, so you're left with x plus 2 squared is equal to 39 over 2. And you're left with x plus 2 is equal to the plus or minus square root of 39 over 2. This is all square rooted. And then you can bring the 2 to the other side, and you're left with x is equal to minus 2 plus or minus the square root of 39 over 2. And those are your two answers for x. You have x is equal to negative 2 plus the square root of 39 over 2, and x is equal to negative 2 minus the square root of 39 over 2. So that's completing the square. Now let's do the quadratic formula. So if you don't want to complete the square, the other way you can solve this is by using the formula. And the formula says x is equal to minus b plus or minus the square root of b squared minus 4ac everything. Let's make a line actually. Let's make a proper line because this is an important formula. So all of this is divided by 2 times a. Remember, you had ax squared plus bx plus c is equal to 0. So you have to make it in this form first. So if you remember when we were doing it over here, when we had this equation right here, you had to make it into this equation to be able to use the quadratic formula. Otherwise, you will not be able to use the quadratic formula. So keep that in mind. And another interesting thing that this tells you, even completing the square can tell you the exact same thing, but what this formula can tell you is if this number right here, right? Or in fact, not even the square root, just this thing right here, b squared minus 4ac. So b squared minus 4ac. This is known as the discriminant. That's just the name for it, discriminant. And what it does is it tells you if this equation even has a solution. So if b squared minus 4ac is equal to 0, right, then this whole thing inside the square root will just be square root of 0. So if you, whatever numbers you have over here, right, if you add or subtract 0 from them, it doesn't matter. You will still have that same number. You'll just have minus b divided by 2a at the end. So you will only have one solution or one root to the equation instead of having two solutions. Of course, if b squared minus 4ac is a normal, regular number greater than 0, then you have two distinct solutions. Distinct just means they're different from each other. Because sometimes the one solution is also called a repeated solution, because it's two solutions, but it's just one of it repeated two times, if you want to think of it like that. But honestly, just one solution. But if b squared minus 4ac is less than 0, well, of course, then you can't take the square root of a negative number, or not yet anyway, right? So this will have no solutions. So you can see that b squared minus 4ac is actually very helpful. And the same thing will happen if you complete the square. If you complete the square for an equation that does not have a solution, you will end up getting a negative number on this side, and you'll have to take a square root. And straight away you will know that, okay, I cannot take the square root of that, so there's something wrong, or this thing does not have a solution. And yeah, so that's completing the square, and that's the quadratic formula. So quick recap, completing the square. If you have a coefficient in front of x squared, just get rid of the coefficient by dividing everything by it. So in this case, we divided by 2, so we are left with x squared plus 4x minus 31 over 2 is equal to 0. And then what you do is you take b and you divide it by 2, because you divide b by 2 in all cases, not just because there's a 2 here, by the way. Like over here, when we solved this equation, we also divided 3 by 2. It's just how it is. As I said, I might show why in another video. So you divide it by 2, and you put that in front. By the way, if this was a negative number, if it was x squared minus 4x, then this would be x minus 2 all squared. And then once you have that inside and you open the brackets, you will end up getting a number, right? So in this case, we got 4. And we want to go from 4 to negative 31 over 2. Well, to do that, you subtract 19.5 from it. So we subtract 19.5 from this, and we equate that to 0. Bring the 19.5 to the other side, and then just solve normally, and you will end up getting 2 roots for that particular equation. Quadratic formula, this is just the formula the way it is. You have to make sure you have it in this form first, otherwise you won't be able to use this formula. Make sure that you don't get confused with the signs. This is a negative b, this is a plus or minus, this is a square root of everything inside, and all of this in the numerator is divided by 2a. The discriminant tells you how many solutions there are to the equation. So if the discriminant, which is inside the square root in the quadratic formula, if it's 0, then it's just one solution. If it's greater than 0, then you have two distinct solutions. And if it's less than 0, then you have no solutions for that equation. And actually, I'll show you what it looks like. So let's say we were graphing it, right? You can take my word for it. So if the discriminant is equal to 0, our equation would look something like this. Our graph would look something like that. It would just touch the x-axis at one point. If our discriminant was greater than 0, then our graph would look something like this. It touches the x-axis at 2 points. If our discriminant was less than 0 and we had no solutions, then our graph would never actually touch the x-axis. And that's like the geometric interpretation of this. Like, what does no solution mean? No solution means the graph never crosses the x-axis. So yeah, that's quadratic formula. Okay, let's do some questions and get used to the quadratic formula and completing the square. So 7a, factorize fully. 27y squared minus 3. Okay, well, I know 3 is a common factor in both of them, so you have 3 times 9y squared minus 1. And I realized something. 9 and 1 are both square numbers. This is 3 squared and this is 1 squared. So that means this is the difference of two squares. So you're left with 3 times, well, 3y plus 1 and 3y minus 1. And you have to factorize fully. So just factorizing like this will probably only give you 1 point. You need to factorize completely to get all 3 marks for this. So you're left with 3 times 3y plus 1 times 3y minus 1. So yeah. Second one, 2m minus pk plus 2k minus pm. Well, I can just see that you'd have to take the 2's out, so you're left with 2, and then you have m plus k, and then you have minus p, and then you have m plus k again. M from here, and then k from here. Well, this is all just simple factorizing. You're left with 2 minus p and m plus k. You can open these brackets out and you will see that you end up getting 2m minus pk plus 2k minus pm. So this is 2 minus p m plus k. Okay, all of that's not related to what we want to do. What we really want to do are part B and part C. So I know this is going to end up being a quadratic equation because it just looks like it's going to end up like that. And this one is definitely a quadratic equation, and you must do all your work and give your answers correct to 2 decimal places. So let's solve this one by completing the square, and let's solve this one by using the formula. Okay, so solve x minus 1 over x plus 1 minus 6 over x minus 1 is equal to 1. Well, let's cross multiply, right? So let's multiply this and this and this and this and this and this. So you're left with x minus 1 times x minus 1. So that's x minus 1 squared minus 6 times x plus 1, all divided by, let's make the line better. Let's make it a straight line. I'll make it a perfect straight line. All of that is divided by x plus 1 times x minus 1. So that's x squared minus 1, because that's the difference of two squares again. And that is equal to 1. Well, now we can open the brackets and we can bring x squared minus 1 to the other side. So you're left with x squared minus 2x plus 1. That's just opening this bracket. And then minus 6x minus 6 is equal to x squared minus 1. Well, you see the x squares are on both sides, right? So get rid of the x squared. You can just cancel those out. So you're left with minus 2x plus 1 minus 6x minus 6 is equal to negative 1. Well, minus 2x minus 6x is negative 8x, so negative 8x is equal to plus 1 minus 6 is negative 5. Bring this to the other side, you're left with positive 4. Well, x is just negative a half. You don't even have to complete the square, so that's nice. X is equal to negative a half. And you can put negative a half inside here and check if you get the right answer. Let's do it. So negative a half minus 1 is negative 3 over 2. See, let's do it over here. This is like making sure we have the right answer. Negative 3 over 2 divided by negative a half plus 1, that's positive a half. And then minus 6 divided by negative a half minus 1, so that's again negative 3 over 2. Well, negative 3 over 2 divided by a half is negative 3. And then minus 6 divided by negative 3 over 2 is positive 4. Negative 6 divided by negative 3 over 2 is positive 4. So minus 3 plus 4, which is equal to 1. So our answer is correct. We didn't even have to complete the square there. I thought it would be more interesting, but it's a pretty simple equation. Well, this one definitely, you can't factorize this equation. I'll tell you that right now. So let's complete the square, and let's actually use the quadratic formula as well. Let's see which one works better for us. So quadratic formula first. So x is equal to, I'm not going to write the whole formula again because we already have it. It's right here. So minus b. So b is actually minus 3. So a is 4. You have to make sure you get this right. A is 4, b is minus 3, and c is minus 2, not just positive 2. So x is equal to minus 3 plus or minus the square root of b squared is just 9 minus 4 times a times c. Well, a is 4, c is negative 2, so that's negative 8. All divided by 2a, which is just 2 times 4, which is 8. Well, x is equal to negative 3 is positive 3, so 3 plus or minus square root of, this is 9 minus 4 times minus 8, so that's 32, plus 9 is 41. All divided by 8. Well, now you just solved the equation and you want it to 2 decimal places. Let me get my calculator out. So you have 3 plus the square root of 41 divided by 8. So you end up getting 1.175, so that's 1.18 to 2 decimal places. Or you get 3 minus square root of 41 divided by 8, which is negative 0.425, which is negative 0.43 to 2 decimal places. So those are our two answers. Now let's do it by completing the square. So as I said, divide by 4 on all the sides. So you're left with x squared minus 3x over 4 minus 2 over 4, so minus a half, is equal to 0. Well, you divide this term by 2, so you're left with x minus 3 over 8. Just 3 over 4 divided by 2 is 3 over 8. So 3 over 8 all squared. And then what's 3 over 8 squared? Well, that's 9 over 64. So you have 9 over 64, and you want to get to negative a half. Well, what do? You do negative a half minus 9 over 64. So minus 9 over 64 minus a half is equal to 0. Well, you can bring these two things to the other side, so you're left with x minus 3 over 8 all squared is equal to 9 over 64 plus a half. Well, a half is the same as 32 over 64, so you'd be left with 32 plus 9, which is 41 over 64. And then you can solve this equation, but you can see that these are very similar, and of course they're going to be similar because you're going to end up getting the same answer. You can see the 3 over 8, you can see the 3 over 8, you can see the 41 over here, you can see the 41, and we're going to take the square root, so it will become the square root of 41, and it will become the square root of 64, which will become 8. So you can see that completing the square or using the quadratic formula, both can work. The quadratic formula will always give you the right answer. Completing the square will always give you the right answer. Just sometimes one of them is easier than the other. And if you are unsure about how to complete the square, then of course use the quadratic formula. You just have to memorize it. But it's good to know why the quadratic formula works. And it actually works because if you complete the square for this equation right here, this main equation, then you end up getting the quadratic formula. So honestly, this is just an extension of this. So let's just write down our final answer. So x is equal to 1.18 or negative 0.43. And as usual, you can put this back into x right here. So you can put 1.18 back here and 1.18 here. You can check if that equals 0. Or it won't be equal to exactly 0, but it'll be very close to 0. And then you put negative 0.43 back in and make sure that it's almost equal to 0 as well. It won't be exact because we did round these up. We did round these down, or we rounded these numbers, so you won't get the exact same answer. So yeah, that's completing the square and the quadratic formula. So let's do a quick recap of what we learned. So let's do it right here. So we have 4 ways of solving quadratic equations. This is just like where I'm going to write. So one is completing the square. Completing the square. The other is the quadratic formula, QF. The other one is graphing, but we didn't look at that. And the other one is factorizing. And factorizing only works in very specific cases. Like you need to be able to guess what numbers to use. Like this is a very easy case. You can just guess that positive 5 and positive 1 would work. But in more difficult cases, like we saw right here, right? You can't guess numbers for this, even if you divide by 4, right? And you end up getting this quadratic. You can't really guess two numbers that multiply to negative a half and add up to negative 3 over 4 just like that. Like that's going to require a lot of guessing. Instead of guessing, we can either complete the square or use the quadratic formula, which comes from completing the square again, and you'll get the answer to your equation. So yeah, that is all you need to know about quadratic equations. So yeah, like, comment, subscribe, share, all of that. And let me know what you want to see in future videos. Let me know what topics you want to see and what other methods I could use that maybe not be clear, or maybe you have some improvements for me. So yeah, let me know in the comments.